All right, this is section 8-1, finding sums and differences of polynomials. There's a few new definitions during this section, but it's really pretty similar to stuff you did back in chapter 1 and 2, so you should be able to do this with pretty much no problem. Here we go with the first definitions. So these highlighted things, you need to know these highlighted things because I'll be talking about them a lot, except for degree of a monomial. I will not be talking about monomial degrees. It's not really important to me, but if it was a longer year, I might. So up here at the top, it says a polynomial is a monomial or the sum of monomials. Each is called a term of the polynomial. Some polynomials have special names. A binomial has 2 monomials, and a trinomial has 3 monomials. So here it shows a monomial is 5x, a binomial is 2x plus 7, and a trinomial is x cubed minus 10x plus 1. How do you know how many terms there are or what a different term is? The way you figure out where the terms are is if you see a plus or a minus sign, then that means it's a new term. So for a binomial, the first term is 2x squared, the second term is 7. And then for the trinomial, the first term is x cubed, the second term is negative 10x, and the third term is 1. So hopefully that clears up what a term is. And you can have more than just a trinomial. You can have 4, 5, 6, as many terms as you want. We just call those generically a polynomial. So monomial is 1, binomial is 2, trinomial is 3, and polynomial is anything more than 3. So I'm going to skip this next paragraph where it says degree of a monomial and go down to degree of a polynomial. The degree of a polynomial is the greatest degree of any term in the polynomial. You can find the degree of a polynomial by finding the degree of each term. Polynomials are named based on their degree. So if you look at the monomial, the highest power is 1, so that's a first degree term. Binomial, the highest power is second power on the 2x squared, so that's a second degree polynomial. And then trinomial, there's a first degree and a third degree in here, but we're going to call it third degree because 3 is bigger than 1, so that's third degree. The names are out here. I don't think it's important for you to know all the names in Algebra 1 as in Algebra 2, so we won't worry about that, but just you need to know what a degree actually is. Standard form of a polynomial is important to know. So it says the terms of a polynomial can be written in any order. However, polynomials in one variable are written in standard form, meaning if you just have x's and no other variables, you should be writing it in standard form. The standard form of polynomial has terms in order from greatest to least degree. In this form, the coefficient of the first term is the leading coefficient. So as you can see here where it says standard form, it's 4x cubed. The greatest degree is the third power, minus 5x squared. That's the second greatest power, plus 2x, which is first power, plus 7, which is no powers. So you need to put your terms in order of degree from highest to lowest. Whatever the sign is in front of it always follows the term. So if there was no... if you had to rearrange these, the negative would always be in front of the 5x squared no matter what. It would never change to a plus 5x squared. It would always be a minus 5x squared. So let's look at a couple of examples. These are in your book as well, but I'm just going to talk through them because it's pretty easy to talk through them. So this says find each sum, 2x squared plus 5x minus 7 plus 3 minus 4x squared plus 6x. When you're finding the sum, it's literally combining like terms just like we did in chapter 1 and 2. You just combine like terms with only the same degrees together. So in this one, we're always going to focus on the horizontal method. If we had more time, I'd show you the vertical method. We don't, so we'll just worry about the horizontal method. You find all of the x squareds because that's your highest power. So in the first set of parentheses, you have 2x squared, and in the second one, you have a negative 4x squared. And as you can see down here where it says group and combine like terms on the second line down, the 2x squared is being added to the negative 4x squared. Then you group your first degree terms together. So that's a blue 5x from the first parentheses. And then that's a plus 5x, by the way, so it's positive. And a plus 6x from the second parentheses, which is also positive. And then in the third set of parentheses, we're grouping the negative 7, which is your constant from the first parentheses, plus 3, which is your constant from the second parentheses, and they're grouped in green over there on the right. You don't have to put those brackets when you do it. That's just the book trying to show you, like, here's one group, here's another group, here's another group. If you group them like that, then you already have your degrees in order from largest to smallest. Here the red is second power, it's the largest. The blue is x to the first power, it's the second largest. And then the green is the constants with no degree at all. So down here, if you add 2x squared plus negative 4x, you get negative 2x squared. So we write down negative 2x squared on the next line. Then we combine like terms for the blue. 5x plus 6x is 11x. And then we combine like terms for the green. Negative 7 plus 3 is negative 4. And then you're done. That's completely finished problem. We're just finding the sum. We're not doing anything to the sum. It's negative 2x squared plus 11x minus 4. If you had those out of order, it's still correct, but sometimes it'll say in standard form. And if it says in standard form, it needs to be written in standard form. Subtraction is almost the exact same thing. So we'll look at this one, and you'll see there's only one difference in the first step, and then after that, it's completely the same. So it says find each difference. We've got 3 minus 2x plus 2x squared in the first group, and then minus 4x minus 5 plus 3x squared in the second group. So what we're going to do is we're going to do the additive inverse. So down here it says in the first line, they rewrote the problem and color-coded everything by degree. So the constants are in green, the first degree terms are in blue, the second degree terms are in red. All right, and what you do, look at the first colored line versus the second colored line. They changed the minus to a plus in between the two sets of parentheses. And then they changed the sign of everything in the second parentheses. So the minus changed to a plus, then everything in the second parentheses changed signs. 4x became negative 4x, minus 5 became plus 5, and 3x squared became negative 3x squared. After that, you just add it like before. So again, change the minus to a plus, change all the signs in the parentheses, and then just combine like terms. We're going to start with the highest degree. So from the first parentheses here on the second colored line, we have 2x squared in red. And then over on the right side in the second parentheses, we have negative 3x squared. So we're going to group them together. Then we're going to do the same thing with the first power variables, which is negative 2x from the first parentheses and negative 4x from the second parentheses. And they get grouped into that second bracket. And then finally, we group the constants together. That's positive 3 from the first bracket and plus 5 from the second bracket. And we're going to put it in here at 3 plus 5. Just combine like terms. We have 2x squared plus negative 3x squared, which gives us negative x squared. The second bracket, we have negative 2x plus negative 4x. That's a negative 6x. And then 3 plus 5 is 8. And then your final answer is negative x squared minus 6x plus 8. It's already written in the correct order because of the way we grouped it. Finally, here's a word problem. It says here the equations P equals 7m plus 137 and C equals 4m plus 78 represent the number of cell phones and digital cameras sold in months M at an electronics store. Write an equation for total monthly sales of T phones and cameras. Then predict the number of phones and cameras sold in 10 months. So all you have to do is take those two binomials, 7m plus 137 and 4m plus 78, and figure out, am I adding them or subtracting them? If you look in the bold text at the third line, it says, write an equation for the total monthly sales. When you total up anything, you're adding them together. So what we're going to do is take here, down here, it says to write an equation that represents the total sales, T, add the equations. So all we're going to do is take 7m plus 137, which is the first binomial. We don't have to worry about the P. And then 4m plus 78, which is the C. And we're just going to combine like terms by grouping just like before. 7m plus 4m is 11m, and 137 plus 78 is 215. The problem in the bold gave you two things to do. First, it said write an equation. The second sentence after that said predict the number of phones and cameras sold in 10 months. So what does this say to do? Substitute 10 for m to predict the number of phones and cameras sold in 10 months. So you take out the m, you put 10 in parentheses to replace it, make sure you use parentheses, and then you use order of operations to finish the problem. 11 times 10 is 110, and then 110 plus 215 is 325. Therefore, a total of 325 cell phones and digital cameras will be sold in 10 months. All right, so you should be watching this video. There's a link right here on the Google Classroom where you click to find this video. There's also an assignment here. That assignment is what you're going to be doing Monday and Tuesday in class. So make sure that you've watched this video, you bring your book, or at least have it up online so that you can do these problems in class. Good luck. I hope to see you guys on Wednesday or Wednesday at the earliest, maybe Thursday next week. I hope you have a good rest of your week, and I'll see you soon. Bye-bye.